So we have a class A, we have a class B, and we have a class C. So A is some kind of, I don't know, base class. Not really, it's not actually a base class at all. It's some kind of like program class that has the void function to maybe run everything. Maybe this is like a main function or something like that. And then we have B and C, which are kind of our two classes here that are used, and B is some kind of superclass of C. B is some kind of cow, and C is some kind of duck. And so what we're doing here is we're creating some kind of duck, then we're asking the duck to speak. And apparently ducks are cows, but whatever. And then we're having B, then we're basically grabbing our value of C here, and we're kind of reinterpreting it to be a B, and then we're asking the B to speak, and then we're creating a new B, and then we're asking the B to speak, and then we're once again also asking the C to speak. So the question here is, what is the output? What does this first speak say? You don't have to tell me them all at once, just go one by one. So if we create a new C, and then we do speak, people think quack. People think quack. Yes, so it's going to print quack. Now that one's not too difficult. I mean, you can just see it points here. But for this next one, this is maybe where it gets a little bit more difficult. So if we reinterpret C and we tell the compiler, hey, I know you're thinking of C as, this object here, this type C, but instead I want you to think of it now as type B. And so do some kind of cast here. And then I want you to make it speak. What does this one print? Does this one still print quack? Does this one print moo? Isn't it also quack? Moo. Okay, so it seems like most people are thinking quack, but there's still some people who are thinking moo. And so this is actually a really important point when we're talking about kind of OO and we're talking about like type inheritance and stuff like that, is this concept of overriding, right? And so one of the things that we talked about in the first week was we had a bit of C code, and we had this shouter class here, right? And we had all these kind of methods. So we had the ability to call the shout function, and it looks like this. So it looks like some kind of function to make a shout. And I mentioned, this changes a bit when we talk about inheritance. And this is kind of where this comes in. And so how it works is, and I'm not going to do the C code for this because I don't really want to get into vtables. I'll instead just kind of draw it. And so the idea is that when you have an object like our duck here, right, which I'm going to call C, and this object has a method called quack, right? Or has a method called speak, but it quacks, When we have this object inherit from B, all this is doing is grabbing this function here, this little executable block, which is our speak function. And it's basically pointing this speak function to quack. So you can think of it as like the function is like a variable that's changing. And so what happens here is you kind of get this two-stage initialization. So when I allocate a class, right? So for example, when I'm allocating C, I allocate the memory for C. And inside this memory, let's say it's however many bytes, it's going to have a few blocks. The first one is it needs something for type. So typically it has some kind of type block, which contains a bit of information about the type. And then it has all your variables and everything else after that. Now this type block is where overriding or virtual methods basically go. Oh no, Reese. Internet dropped out. I mean, I feel like it's just the quarantine vibes, is that the internet just becomes so much more unstable. And so this type block is basically just like a big kind of object of functions, right? And every type has like a unique block. Now it gets a little bit more complicated when we're talking about the concept of casting, because then you're talking about like, how does this block change? And like, it's a little bit more complicated, but let's just like kind of stay away from those really kind of specifics that don't really matter in this course and just kind of stay at like this kind of general abstract level of, oh, we have a series of functions. And so, for example, you would have some kind of speak function in here. And this speak function is basically what's being assigned. And so you can think of it that when you go and create a new C, it's going to go and grab the type block for C that describes what C is. And go, oh, here's my speak function inside of that. And so every time you call the speak function, it's actually going inside here, grabbing the variable, then calling that variable. And so even though you're changing the view of the object here, even though you're changing the type, quotation marks, like what C actually is, its identity, what functions it can call underneath don't change. It's just like the view on top that changes. And so you're able to do this kind of concept of casting. And so what you're doing is you're basically you're not like changing the data, you're changing like the perception of that data. And so that's what like changes what functions you can call and stuff like that. But when you call those functions, you still get the same results as you got before. And that's kind of the whole point of overriding. That's kind of the whole point of inheritance, is that you kind of get this consistency. Otherwise, for example, if you have a satellite class, and then you have some kind of inherited derived version of that for, let's say, a satellite that is I don't know, sad. And whatever this sad satellite does, you still want to treat this sad satellite just as if it's a normal satellite, right? You still want to be able to make it move around, even if half the time it decides it doesn't want to move, right? And so if you kind of make these kind of abstract choices about satellite, even though when you put it into your array list or however you're storing this specific satellite, even though you're putting it in as a satellite and all your functions see it as a satellite, it doesn't change its underlying identity that it's still a sad satellite. Which is the slight analogy. We're going to make it happy. It deserves a happy life. It's a happy satellite. It's twice as fast. Sad. And anthropomorphizing. I can't say that word. Making them animalistic. And so what you're having here is you're having this kind of ability to get some consistency about your types, to say, hey, to be a satellite, to be an animal, you have to have these functions. But you get this flexibility to allow you to kind of change certain aspects of that behavior for certain derived classes. And so that flexibility is really kind of fundamental to OO. And it's really basically this entire point of this course. And so that's one of the reasons why this kind of still says crack, because it's still a duck or whatever C is meant to be, even though we're currently viewing it as B. And, if I create a new B here and I ask B to speak, it's going to say moo. And if I ask C to speak, it's still the same object as it was before. So it's still going to say quack. And so you still get that kind of consistency there. So it's going to be quack, moo. Sorry, quack, quack, moo, quack. Yeah, I made the same mistake just then, right? So quack because of the C, quack because of the typecast. It doesn't change it. This is going to be moo because this is a B. And then this one will be quack because it's still the same object. And then, we have the same kind of class here. And what we have here is we have got two incremental functions, and we have B, and we're creating two Bs. We're incrementing them separately, and then we're printing out the two values. So we're incrementing one with X and one with Y, and then we're printing out the first X and the first Y, and the second X and second Y. For this case, what do people think is the solution? What would this print out? The first one, at least. 1, 1. So does b1 to increment x, b2 to increment y? And you think 1, 1? Why 1, 1? Anyone tell me? Yes, that's the first question. Is x and y are initialized to 0 by default? Is there anything special about y? Thank you, Tom. So static means it belongs to the type, not to the instance. So if we go back to our analogy here, we go back to our analogy here, a normal member like x would lie in this bit of memory. It would belong with each instance. A value like y would kind of lie like here, in this kind of type block that they all share. It's not really true, it kind of lies in a different place, but it's like roughly around this kind of idea. And so basically it belongs to all of them at once. And so you kind of have that fact that if you change one of them, the other changes. The police are here. And so final does mean constant, yes. I don't know why they call it final. I guess because it's like the final value, obviously, but like it's still a bad name for it. So yes, this is going to print 1, 1 because 1 for the x increment and then the y increment, so 1, 1, where this one will print 0, 1 because the, in this case, the x has not been incremented for b2. And we come back to this question about can you override a static method? And the reason why you can't override a static method is because it belongs to all of the classes at once rather than belonging to like belongs to like the type rather than belonging to the kind of blueprint, if that makes sense. It's kind of like a static method is not like, it's kind of weird because I'm like, this is kind of what belongs to types and like static variables are kind of here, but like static methods are not. And it's kind of just like how it works in that like each type has their own kind of like type object here, which like, as I said before, the type block kind of refers to all that type specific stuff. And you can kind of conceptualize static methods as existing inside this type block. And so what that means is that you can't override them because they don't belong to like the class kind of template. There's no like, hey, for you to be C, you must have this function. It's just like every C shares this function. So if you have a B, which is a C, it's kind of confusing. Let me explain it a different way. It's a weird way of explaining it than just saying, no, it doesn't work, because I'm trying to explain why. It's like this, right? So if you have a cow, right, there's some functions inside that sit within a cow that are unique to the instance, such as, for example, maybe to get the color of the cow, because every cow can have a different color, or for example, to get the health of the cow, because the cow may be sick or may be healthy or may be happy, I don't know, whatever. But there's some things that don't belong to like the instance of a cow, but belong to the type of a cow. So an example could be, for example, maybe like get possible colors. Like, hey, get me every possible color for a cow. And this would return like a list of all the possible colors that a cow can be. Another one may be, for example, create cow, right? Like a constructor. Which is one of the reasons why you can't really override constructors. Because they're just basically static methods. And so you kind of have these kind of things that these are more like typey things. These kind of belong to the type rather than belong to the instance. And so, for example, I inherit from cow and I have a different kind of cow that's, I don't know, a duck cow, like before. Then even though this inherits from cow here, it doesn't matter because it can override these instance-specific methods, but it can't override these static methods because the static methods belong to the type, which means that whenever I'm specifying that I want to call these functions, I've got to call it through the type. So for example, if I want to get all the possible colors for a cow, I'm going to say cow.get get possible colors. Let me just infinitely better way of doing this. Cow dot get possible colors. That's how I'm going to call it. That's how you call static functions. Because again, they belong to the type. Which means there's no way for me to override this because, like, what's the concept of duck here, right? If I want to have a different function, I can have a different function called duck cow dot get possible colors, right? But in this case, I'm not overriding the cow one. I'm just having a different function that's just for the duck cow, if that makes sense. And like, you can't call static functions through an instance because they don't belong to the instance, they belong to the type. Yeah. I think that's the easiest way of saying it is like, since you can't call the function through the specific instance and you have to call it through the type, in all cases, you always know what the type is. And so the point of overriding is that you don't really know what the type is, and the type is kind of abstracted away from you. Yeah, so in that case, if you have a list of cows and you add the duck cow to that list, so the question was, hey, I have a list, and this is a list of cows, and I want to add my duck cow to this list. What's going to happen is this duck cow is going to be casted to a cow automatically for you. But you can cast it back to call the methods that are unique to duck cow. If you want to call the overriding methods, you can just call them. Because that's the whole point of inheritance, right? Think about this first example here. When I call speak, I am calling the override methods for this function here. There's no need for me to have to cast C back to the original type. So you have access to the override methods in terms of the fact that you have the implementation of those. But if duck cow goes and implements a bunch of new functions, for example, it implements one called get bill, right? You're not going to get access to this function if you read objects from this list, because the objects that you're reading from this list are cows, not duck cows, right? So you kind of lose that level of it. Exactly. Because the identity of the object is not changing. The object that you have is still a duck cow, right? So it still has those override methods. It's just that the view or the perception of the class has now changed. And so it's almost like you have like a big square here, right? And this is your duck cow. I'll just kind of explain it just for those who maybe still don't understand. And you want to go and you want to change the perception of this class so that you can only get access to functions that exist within a cow. So this is your cow subclass, right? So for example, the cow has access to things like color and health, right? They're the two things that this cow has access to. Whereas this has access to also the bill method. And so what happens when we are doing this cast? Yes, the duck. So the duck cow is orbiting around the planet. How would you handle the duck cow transferring bread to the other cow? Anyway, so when you're changing this perception here, you're basically almost like putting a magnifying glass over this class, and you're just seeing just this. It doesn't change the fact that this still exists. It's just what you're seeing has changed, which means all the override methods are still overridden because this is still the same object. So these methods, regardless whether or not you call them through the outer object or whether or not you're already here, you just call them here, doesn't change a thing. But you kind of get that fact that you like lose access to all this stuff up here. Anyway, so if it doesn't increment I, because it why static, then why are you calling it object? So BJ, you were asking a question about this one here, and you said, hey, it does increment y in this case. Do you mean it doesn't increment x? Static variables can be accessed from wherever because they're like, again, they just belong to B, right? Okay. Let's move on. Let's look at our UML diagram. Actually, I won't come to the UML diagram towards the end just because not really in the mood to do a UML diagram right now. We'll come back to it in like 10, 15 minutes, which is the mood. And so we're going to look at the wondrous sequence and the IDE stuff and kind of look through all the debugging because that's more helpful towards your assignment, like right now to fix issues. And we'll still do UML today, just towards the end. So we have a wondrous sequence. If the current term is even, the next term is half of it. If the current term is odd, the next term is 3 times plus 1. So we have 3 to 10, because 3 times 3 is 9, plus 1 is 10, half the 10 to 5, times 3 is 15, plus 1 is 16, half it to 8, half it to 4, half it to 2, half it to 1, and you just kind of I mean, I guess you would stop at 1. It doesn't really specify that, but like you could still go from 1, right? Like you could just go 3 times 1 is 3, plus 1 is 4, and then you're just gonna go 4 to 1 again. So you're basically just gonna get 4 to 1 repeated from this point. So I presume that's basically the end of the sequence. Anyway, especially since it says if the starting term is 1, then an empty list is returned. So if we look inside wondrous sequence here, we see that we've got a function here, we have some magic number, and we also have a sequence here. It goes, hey, while the current does not equal 1, it adds the current number. If it's even, it divides by 2, else it times is 3 plus 1. Don't know why this exists. I don't know. Is there a reason why this exists? Who knows? Kind of a weird thing for it to exist. Who knows? Anyway, so, and basically, what we have here is we got to fix this bug, and the bug is pretty easy to fix. But we're just going to kind of start at it, and we're just going to find what the bug is and go from there. And we'll see. I'm so confused by this magic number being here. I'm just going to delete it. Goodbye. Cool world. Don't annoy me like that. It's a thing. Anyway, we're just going to then go and add this to our VS Code. 2, 2, 3. And if all life is nice and good to me, then yay, it will pop up and we'll be able to run the test. So this should fail. It does, thank God. And it fails pretty easily, as you can see here. You have this array here, you have this array here, you're missing a 1 at the end. And so the question is, well, how do we debug this? How do we find out what the issue is? I mean, you may have a test like this that fails in the satellite code. And there's a few ways. So the first thing you could do is you could look at the code and figure out what the problem is, and you'd probably maybe figure out reasonably quickly. It's not a particularly complicated problem. But you could kind of break it down and go, okay, well, what's the value that it is? What's the value I'm expecting? What's the difference? So you go, okay, the problem here is it's missing a 1. You could look at this sequence and you could go, okay, what changes when it equals 1? Well, it will break from the loop and we'll be here. This is a precondition, not postcondition, and you can kind of figure out from that, and it's pretty easy. But let's just do this kind of the slower way. And then what we're going to do is we're going to start by looking at some breakpoints. So breakpoints and debugging let us basically stop the code and inspect the code. Now, the one thing I'm going to tell you about is this is something that I think a lot of people make a mistake with. Debugging is really not intended for you to go like step by step through your code. Like you can do it, but it's probably not going to be useful. Debugging is much more useful to just kind of see what the value of things are at certain points. It's kind of like a printf debugging on like an extreme, and you'll find it's much more useful that way if you use it as like a printf debugging tool than if you use it as a tool where you go next step, next step, next step, and you run every line of code one by one. Sometimes it's useful. An example of like where debugging has been really useful for me personally I use it quite a bit at work. But we have this concept called smart data, which is basically where, I'll just turn it back on chat just in case people type things. Time to prove Colette's conjecture. Oh, I thought I released all my solutions. I'll double check, make sure I released them all. But there will be solutions, obviously, I typically cover pretty much the same content as the course, but I'll make sure there's the solutions to what I was talking about up probably tonight after this. Anyway, we have this concept called smart data, and what you do is you basically take this that's gonna be complicated, so it's not good for that. It's if you really want to look into it, this concept could overlap, and it does what's called a hypercube projection and all some mess. Anyway, but the base idea is that what you have is you have a series of like dimensions, which is like the filters. So, for example, you would have like what year the record is in, and your data would like look like 2001, 2002, 2003, and so on. And then you would have like, okay, what country? And you'd have like Australia. I don't know, India. With a weird D. I don't know, USA, UK, Japan, so on, right? And then what you do is you then slice up your data and you measure something on each kind of dimension of row. So, for example, you can measure like how happy they are. For example, you know how at the end of term you feel on my experience, and one of my experience points is like, how satisfied were you with this course? And you rate from like not very satisfied to very satisfied. That's what we call a driver. Sometimes they're called Likerts as well, and they're basically just like an index rating. And so the bottom two are typically -1, the top two are typically +1, and then the middle value is typically 0, and that's typically how it's represented. And so there's typically not too much difference from the fourth and the fifth one. The uni uses a slightly different calculation method, which means there is a difference, but there really shouldn't be. And so, for example, the score here could be like +1. This could be like plus 0.8 because you have like some people with 1, some people with -1s, and so on. You can have like -1 here and so on. And so the point of this is that you have a very kind of complicated system, and technically this becomes like nth dimensional because every dimension of your cube, as it kind of becomes like fourth dimensional, fifth dimensional, is like every filter that you have. And it just kind of keeps expanding. And so you have this like caching layer on top, and that's a very complicated layer. And so when debugging that, it's very useful because the debuggers that we use are very, very powerful, and they let us go back in time. So we can like repeat a segment of code over and over again. And so we can, for example, set up 2 points in code, we could run it across the two, and then we can look at the values of those code, of like the various different arrays and stuff, and then we can move it back to the beginning, and then run just that section again. And then move it back to the beginning, run just that section again. And you can even edit the code as we go, and it will automatically update. This is C#. C# comes with loads of powers. And so what that means is it's very fast to kind of make changes to it because you can kind of like test as you go. And so for cases like that, it's very useful to kind of go step by step where it's like very complicated and you're like, I actually don't know necessarily what the result of this function is going to be. But in a lot of cases, it's very useful to go, okay, I want to find a point in the code where I don't know the answer. And so what you want to do here is you want to look and go, I don't know the answer of sequence. So I want to look at every point where we add the sequence. So you put a breakpoint there. And then you may also put a breakpoint here, right? So basically every point that you kind of use that variable, you go, I don't know what the value of it is. I'm going to put a debug point there. And then you press right click this, you go debug test. And you hit the point. You can now mouse over these variables and look at the values. This is typically what I do, and I love the debug console. The debug console is actually really, really nice for Java. You can type any expression inside of this and it will evaluate it for you. And you can actually modify variables and stuff like that. Right? See, sequence has our 1 here. Well, let me remove one. Interesting. I think I've broken it for some reason. Anyway, remove 0. remove like the first value from the array. I don't really try to modify things. Interesting how it's kind of evaluated that. Anyway, it's clearly not perfect, but it works really well. And so in most cases, the thing I use this for a lot is to, again, see what the values of things are. You have two satellites and they're not connecting. They're not talking to each other. Oh no, what do? You put a debug point on exactly where your code handles the connection. And then you start writing things. For example, math helper dot is in range or whatever, get distance. And you go, hey, are these things in distance? Yes, they're in distance of each other. Yes, they're visible of each other. Okay, it must be one of my conditions. I can look at this function. It's the only one left. Open it up. Oh, I'm checking the wrong type. Right, click. Think about the cases where, for example, some of you may have used equals rather than does not equal. You put a debug point exactly where you're removing the item from the list and you're going, it's not working. Where you're kind of doing your for loop, you look at that exact if statement and you write the if statement exactly in the debug console and you go, I'm having x and, let's say like var x equals a. I am having x, which is a. That's interesting how you can't create variables that way. Anyway, let me just do it this way. I'll show you that in a second. Let me just do it right now. A equals blah, 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 blah. And what we'll do is we will restart the test so we get to the same point. There we go. What's A? A is that. I mean, you may be typing something like this. Now I've got to try to trick it in terms of not memorizing my string. I think it's going to memorize it if I just copy it, but we'll just try that. Why not? What's the worst? Oh, that's not what I meant. Yeah, okay. It didn't memorize it. Okay. And so in a lot of cases, strings will be kind of if they're the same object. So for example, if you pass an object into one function, string to one function, and then you pass the same string within the same test to another function, it will say true. So for example, if I do this and I do this equals this, I get false because this string is long enough, it's not going to be memorized. So it's going to be created each time, or it could just be the debug console creating each time. But if you kind of do it locally, like a test, most likely that's going to be optimized so it will do the comparison using the equals. And I mean, I can probably just do like a search true. There we go. And I can say something like, I don't know, this equals this. And I can, I'll just run the test like this. And then if I get past the search true, I know that equality statement is true. And look, it was true. Because I got past it, right? I got past this assert. And so therefore, you can kind of see that there's this difference here, and that's basically what trips up a lot of people. Yeah, that's honestly a big rip. It happens to everyone though, and it's Java's fault. It's not your fault. Blame Java. And so what you do here, someone may go, oh, I want to press the step over button. But the thing is, you can spend 20 minutes stepping through every line in this while loop, and it's not going to help you. Because what you really care about is the current pattern. So if you're going to print line debug, it is recording. I'm recording through this. I'm not recording through Teams. I normally do record through Teams. I don't have the backup. I do have the OBS recording, so this should be fine. Yeah. It will just have the recording on WebCMS. I normally do both. I just forgot today. That should be fine because I've got this one back up. You can see here. So it should be there. And so basically what we end up with is we go, okay, we have this sequence here and we're counting all these values. Do I actually care what the sequence of current is? And so the question that you may be asking yourself is, if I was to printf debug this, what would I be printing? That's basically what I want you to ask yourself. And so in a lot of cases, although you would probably be printing the word current to see the pattern. And so in that case, what you would be doing is you'd write the word current here, and you can see the pattern. And so you can see the pattern two ways. You can put a statement here. This is where I'd probably put the statement, because this is basically where I'm checking each time, right? And it's going to go 3, and then apparently stop. I don't know. We'll just debug that. I don't know why that stopped. I think maybe I just pressed the wrong button. I could have easily just pressed like the wrong button there. I don't know. Anyway, so 3, 10, 5, 16, and we can look at our list. Right? Make this a bit bigger. 3, 10, 15, 3, 10, 5, 16, 8, 4, 2. What happened to 1? And that's, you go, oh, I know why. What this is a precondition, so it hits 1 and stops. So it doesn't add 1 to the sequence. Sequence.add 1. And I guess you could add it this way. I wouldn't probably modify your test like this, because it only takes one case where you forget that you did that. And oh, look, the test passed, but like if you didn't like manually do that, they wouldn't, right? So I wouldn't just like modify your stuff to make it work. Just like make the changes and rerun the test. Yay, okay. And then we go into the next point, which is, hey, we have to write a test. And there's one more bug that we don't catch. Can anyone tell me the one bug that we maybe don't catch here? Think about the kind of specification here. And I kind of would show you how this bug would actually be caught once we figure out what the bug is. Let me just do them side by side, maybe. I mean, you don't really need to see the sequence definition. That should be fine. Oh, yeah, let's not do that. I do not have time right now. 0, you can presume it's non-zero. Beautiful. And I've actually just broken a test. So what you would really have is you would actually have a regression test. And this regression test would say, hey, if I ask for wondrous 1, I would expect an empty array list. And this would be my regression test, and this would be passing before I made the change. But as soon as I make the change, oh no, it fails. All right, and this is the point of regression tests, to stop people making bugs in the future. And then you go, except for the case where the start equals 1. And then you add a comment because we're nice, and we say, hey, in the case that the starting term is 1, we want to produce an empty list. Now you could also write that at the very top, and you could say, hey, if start equals 1, return sequence, and say stop early, since a starting term of 1 always produces an empty list. Either one's fine. I would probably write it like this. I prefer having kind of these special cases be at the beginning, but either way is kind of fine. And I would probably be fine with either in a code review, as long as the comment's there. And this is the reason why we have comments, right? I wouldn't comment everything in this function, but in this specific case, it's kind of obscure. And that's it. I'm sure there's other tests I could write as well. I mean, we can show this test pass. I think there's one other thing they want us to do, which is make it throw an exception. I have a slightly more interesting thing to talk about exceptions. So I'm not going to be covering this specific case here, because it's just like, hey, throw an exception. And we'll kind of go into that a bit later. And well, this case here, it's really just because it's what we call a runtime exception, which means it's just not necessary. Some things which are safe exceptions, which have to be caught, and other things aren't. So let's look into our UML, because we should be doing that. Not me procrastinating doing UML. Man, they suck. I've done enough UMLs for my lifetime. So what we're going to do here is we're going to build a very simple UML. I'm going to do it doing draw.io because I want you to have decent practices. The other one is Lucid, and Lucid is perfectly fine. Now, I don't know. What am I going to call this? Cars. Thank you, yes. Oh, that's not really what I wanted, but okay, sure. So in this case, we have a object-oriented model for a system with following constraints. UNSW have decided they'd like to build a system that can show all of the student-built and other cars that they have in order to that's phrased so weirdly. Anyway, they're going to show off a bunch of cars to people, and they want to produce an idea of what that system looks like. Every car has a series of engines and a producer. The producer is the person who I presume made the car. And then there's also there's also a few other things here as well, such as engines have a manufacturer. There are only two types of engines. Thermals have a speed of 114 and blah, 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 blah. There's a bunch of text here. Let's not get too bogged down into the text, and let's just jump directly into the interesting part of this, which is just the UML, right? And so if we're going to do this, so then we can do this. Okay, so what I care about here is trying to figure out some way to handle this kind of structure. And so what I'm going to do is I'm going to start off with a car. And I'm going to make this a little bit bigger so people can actually maybe make my screen a bit bigger. I just want it to be more easy to see. I didn't actually mean to do that though. I do actually want that. Anyway, so I have my car here, and this car will probably have a bunch of stuff in it, but to begin with, we will want an engine. And it says one or more engines and a producer. So I guess it's going to have a list of engines. Already I'm noticing problems in the sample solution, but we'll ignore that. And the next thing it has is a manufacturer. Here's my thing about this is I know people will go and create a manufacturer class, but the question is why? The manufacturer only has a brand name. I'm not interested in a class. Just store a string. Keep it simple. If your objects are simpler and less kind of complicated, overall it will make it better. The problem can often be where people kind of overcomplicate things. Even if, for example, you have manufacturers in both a car and also the engine as a manufacturer, and wow, they could be the same thing, it's okay, just have a string until you need it to not be in string, until you need it to actually be a class. Unless you know you're going to need it to be a class, you're just kind of putting in a lot of extra work and a lot of extra abstraction for something that really is just a name. Now, next thing is an owner. Which funnily enough is just completely non-existent from that sample solution there. I don't think an owner is important to put in within the car. If I have a car, the fact that I own it is my problem, not the car's problem, right? The car doesn't have to maintain who owns it. That's just where it currently is, basically. So again, simpler, right? A get engine. Yeah. So we have the ability to get an engine. This is going to return an engine. But I guess the question I have is, why do you care about getting an engine? I don't care about getting engines. I'm not going to have it. Because, like, to me, the problem of getting an engine here, I'll leave it empty just because I will probably want something. I'll probably want it's like when you create a car, you give it like a list of engines. And you give it a manufacturer. So you'd make manufacturer if it has more attributes. Yeah, if it has more than one, I'd make it. Or if I know it's going to have more than one in the future. Or if it has any interesting behavior, I can delegate to it. In this case, I don't really see any interesting behavior to delegate to the manufacturer. And then you have this kind of concept of, hey, I want an engine. Which I can just zoom out a little bit for. And my engine is going to be some kind of connection to my car here. And we're going to figure out what this arrow is in a second. How do I change the arrow type? I thought it was just here. Maybe it's because like the screen's not big enough. Have they changed this UI on me? Probably. Line. Yeah, that one. Oh, here we go. And for now, we'll just say none. And then what we're going to do is we'll kind of come back to this. And we also need to put cardinalities and stuff like that. But for now, let's just keep it simple. So every engine has a speed. But you notice that like I could also go, well, in this case, I could just have a list of speeds. Like, why even have engines? But like engines are something that I know I'm going to want more behavior with. So like it's fine. It actually makes sense to make them class. And especially if they also want a manufacturer, which I think they need. Yeah, or they said producer, but like I hate the mixing between terms of a producer and a manufacturer. Just manufacturer. Keep everything consistent and your life will be easy. Engines. Now every engine needs a speed and also needs a manufacturer. Now you notice here that these have different max speeds and these max speeds can change. And honestly, the first thing is these are all max speed. So calling this speed, I'm actually going to call this max speed. I think calling it speed is actually going to be worse. Right? So they all have different max speed values that can change, which means if they want to be able to change, I'm going to need to add a function to the parent to let you change the max speed of the engine. And I know I'm mixing styles here, so let's just make it a little bit more consistent. Make sense? Perfect. And then the final step is, hey, now I want this subclass of my thermal engine to inherit from this engine here. Let me just do that. Then I need to use the inheritance arrow, which is this one. And the other way around. How do I flip it? Reverse. There we go. And I could just make it bigger. It's a chunky one. Okay, there we go. And I can make it a bit thicker as well. There you go. So just to make it a bit easier to read, because I know that sometimes these things can be a bit hard to read across the screen. And we'll come back to these arrows. And then the next thing we have is, can I make this a little bit more? Yeah, there we go. Oh, beautiful. Then I can create another one. Let me just bring this all the way over here. This other one is the exact same thing, but I guess I'm just going to draw it downwards. There you go. That's fine, just like that. And then it's kind of a bit wonky, like with the positioning of it, but it's fine. I'd probably make it nice and balanced, but I don't really care because I don't really have the time right now. Now, electrical engine also exists. Now, these don't need speeds. These don't need anything. But these do have specific requirements upon their constructors. Now, I'm not going to actually allow you to change the max speed via the constructor. You're just going to specify as the manufacturer because there's the default speed. So if you want to set the max speed, you're going to have to use the setter because we actually want behavior from the setter that's conditional. So we're saying, hey, only anything that's divisible by 6. Now, we'll find out that this kind of restriction is kind of breaking LSP. Because like the parent class says, oh, you can set my max speed to be whatever you want. And then now the subclasses are saying, well, actually, no, you know what? You can't do that. There's specific requirements on this. So what I'm actually going to do is just write it as usual. And then next week, when we have a bit more time, I'm going to show you a slightly different way you can write this code to get around the LSP issue and to actually end up removing the need for these subclasses. And you kind of make everything a bunch cleaner. Anyway, we'll go through that next week. So, hey, this is the max speed that I want to try. And the result of this will be a Boolean. You can see now this is optional. It's not guaranteed that you'll be able to set the max speed. Okay, does that make sense? Cars are able to drive to a particular location XY. Again, I don't love this idea of like... The problem with like this concept of driving is that to me the position... The car really has like no real care about what a position means to it. Like a transform is probably something I would tag along with the car. It could be like part of the car, sure, but it wouldn't be something that the car itself manages. I would probably have some kind of parent class called entity, because in this world, I'm sure many things want to move. And the entity would have like a position and would track the position, and then the car would simply just apply a force to the entity, then the entity and the physics system would all resolve that. So what you're doing is you're kind of making everything else do the work. So the car can just be a car, rather than the car also has to like, figure out the fundamentals of like, mechanical physics, so it can like friggin', turn the wheels and generate a forward moving force. But, it's just... Stop being so, I don't know, devil's advocate, and just try to like write the code. Drive int x, int y. Okay, sure. I can drive to a location. It doesn't really give me a time frame or anything like that, but sure. Like drive to location. And we can presume the car can figure out however it wants to do that. And then we have two special cars. We have time traveling, and we have that's it. Just time traveling. Okay, easy. So then we have a time traveling car, which, as you can guess, was pretty much just like a normal car. And you may have guessed the same kind of conclusion I would have here, which is also like doing this whole inherited thing doesn't really save you from anything, doesn't really help you with anything. And it's probably better in this specific case to actually, instead of using inheritance here to kind of track a time traveling car, you just have the concept of an entity that can time travel. And so every entity tracks the time. And so if you want to move an entity through time, you can just like move it through time. You just like have this like outside concept of time. Because otherwise, like, what the car itself is going to manage what like a different time means. So if you have like two cars moving on the road and one's at like a different point in time than the other, like that's going to mean something. Like it just gets also complicated so quickly when you get every object having to manage all this state. Right? Then now suddenly your cars are moving. You have to check if the other car is in a different time zone, and then like figure out, okay, well within my time, what would that be? And like it's like what, my head explodes. I can't figure that out. Right? Anyway. And so time traveling object has like some kind of time current date that it manages probably. And this also probably has some kind of like location it manages as well. But we're just gonna like leave that stuff out and just say like, hey, we have a time traveling car. And it has all the usual stuff, but you can also time travel to a specific point in time. Even though, again, it would probably be an offset. Like, you wouldn't really be like, hey, travel to this exact second. You'd probably be like, travel 10 minutes in the past or something like that. And you could also have some kind of interface here. to say, hey, anything that's time traveling has this time travel function, right? And then therefore this would utilize this function, and we could reverse that and change the style of this to be a implementation error. Now, the problem I kind of have again with this is that like you kind of end up with the case where you're like, oh, I just have some random interface here. Like, why does this exist? Like, I'm not having multiple objects time traveling. And if I do, am I going to like copy and paste the same time traveling code against each class? Like, that doesn't really feel like an interface thing. Like, is a time traveling car really that different from a time traveling bus? Or like a time traveling, like, I don't know, police box or something? Yeah. You need to be able to apply it to all vehicles. That's why I'm kind of saying like this concept that like you would need like a specific time traveling car is kind of crazy because that's gonna have to write the exact same code as a time traveling bus or whatever, right? So like the interface doesn't really make sense because the way a car time travels is probably not going to be different from the way anything else time travels. And so in that way, really what you're looking for is more like a component that kind of like sits along with the entity. And so what you would have is and this is to be how gamers do it, they have like some kind of entity object, and then the entity has a series of components that sit within it. And one of those components could be like a position, one of them could be like a time frame, one of them could be like whatever. And then you would have like, okay, hey, I want a time traveling car. Well, that's just comes with the territory because it has a car component and it has a time traveling component, right? So you kind of get this like multiple inheritance, but not really. It's much cleaner. And you get to be able to reuse a bunch of things. Anyway, we can go into that later. Let's not do that now. So the relationship between this, we have many engines and we have one car. So we would put an asterisk here to indicate many, and probably a little bit bigger text, like I don't know, 40. And then we'd put a 1 to indicate, hey, you have one car per engine, right? Because two cars can't share the same engine, basically. If they can, then it's fine to put them under the same thing. They can share the same type of engine, but not like the exact same engine. And then we need an arrow here, and we've got two possibilities that we can choose. The first possibility is a closed diamond, and the second possibility is an open diamond. First that, make that bigger. Can anyone tell me what the difference between an open diamond and a closed diamond is here? And which one should we choose? So one is composition and one is aggregation. Yep, and closed means composition, means they can't exist independently. Which means that you destroy the car, you destroy the engine. So there's like an ownership there, but that you also can't like remove the engine from the car. It's like important to the car. And open would mean that they can exist independently, or the ownership is kind of more flexible. And I would say I can remove engines from cars, I can add engines, I can create engines separately from cars. They really don't have any kind of strong ownership there. It's kind of quite weak, in which case this is a white diamond. That's it. Very simple class. And again, it's funny, I hate doing exercises like this because there's so many little things you go, oh, I could do this way or this way and so on. Okay, there you go. There's a cars, and then we can go and we can export as. Well, you could have an engine, but engine's like really generic. Like, what if you had like an engine for like I don't know, a boat, or an engine for like a truck? I know the engines are going to be different, but like the concept of having a engine is going to be the same. It's like conceptually, it doesn't belong to it. Anyway, I'm going to export as a PDF, and then I will attach this to. Thank you. That's not at all the UML I did, unless like somehow included like a bunch of it did included a bunch of other stuff for no reason. Okay. Sure. We're just going to that's from like a previous assignment. We're just going to grab all this, copy it, create a new one. Thank you. paste it in here, export as PDF, and download. Oh, that's nothing. There's some truly interesting ones. Yeah, that's the PDF I wanted. Okay, let me just do this properly. Good to see. Export as advanced PDF cars. They help no one, but they make someone up the top feel very important. So, like, I don't know. UMLs don't really help anyone in real life. They're really kind of useless. That's everything. Yay, look at us. We finished somewhat on time. I kind of want to talk about constructors, but I don't really think they're relevant for this week. So we'll just kind of go into some actual stuff so that we don't go too much over time this week. And we'll talk about them a little bit next week. Probably. Anyway, is there any other questions before I finish up here?